Hi guys, Olive Badger here. I had the most fantastic opportunity to work with Ross from Accursed Farms and Matt from Alderon Games on a video outlining how, as developers, we could assist in stop killing games, and outlined examples of what an end-of-life plan might look like, and addressed a lot of questions that we've been seeing from other software developers. It's a pretty long video, and I will go ahead and link the video in the description and the pinned comment. I highly encourage you guys to check the whole thing out, but I'm going to be posting a couple of smaller snippets from this video for you guys to check out, because I really want to make sure the Stop Killing Games movement succeeds here. And yes, we have blown past the signature requirement in the EU, but we have until the 31st of July. We want to make sure that they hear everyone's voices. So if you are in the EU, please consider signing that petition, and links for that will also be in the pinned comment as well. Hi, I'm Olive Badger, and I have been asked to help with the Stop Killing Games initiative and talk a little bit about some of the common questions that we're seeing from developers. Little bit of background on me. So up front, I'm not a game developer. I have 5 years of IT experience working in various different parts of the industry, doing data center to internal IT and IT management. After that, I transitioned over to software development, where I've done a decent amount of embedded software development for drones, and then moved into full stack development. I've even done a little bit of DevOps and project management for a small startup. So while I am not directly a game developer, both my husband and I love video games. My husband a little more so than me, because he's been playing his whole life. He got me into video games a few years ago, and prior to the Stop Killing Games initiative, he's been wanting to go through a lot of these older games with me, and every time he goes to talk about it, he just hopes that it's still available, because he wants me to experience some of these games that he played as a child. And with the Stop Killing Games and a lot of these developer questions kind of floating around, he asked me what I thought about it, and I was able to utilize my experience and a very specific skill that I have for Google and just loving to learn new things, to dive deep into this issue and actually see how developers could be able to do an end-of-life plan, because this is something that we do in standard development all the time. Not necessarily end-of-life, but we have to support legacy code. We have to solve problems that have no solution. I have had to invent a test scenario for a chip that the manufacturer themselves didn't even know how to test. Like I had to help on that project, and was kind of my main priority for a little bit. So I just wanted to kind of help and put my thoughts out here, and have been working with Ross and Matt from Alderon Games, and we came up with a list of questions that we've been seeing people ask, and came up with some answers that hopefully help you out. Anyway, that's just me. I do have a YouTube channel that just kind of popped off with this whole thing. It's just Olive Badger. So let's get into this PowerPoint presentation, where we will talk about the different ways that you could stop killing games as a game developer. This presentation is based on the Stop Killing Games initiative, which advocates for ensuring games remain playable even after official support ends. So today we'll be covering practical implementation strategies, technical approaches, and real-world examples of how to preserve your games for your community. First up, what are some possible methods for end-of-lifing your game? Before we dive into the technical details, let's establish the 3 primary approaches for ending the life of your game responsibly. The method you choose will depend heavily on your game's architecture, technical constraints, and business considerations. So first up, we have option 1, which is to release private server files or support peer-to-peer sessions. This is often considered to be the gold standard for game preservation. When you release private server files, you're essentially giving the community the tools they need to host their own multiplayer servers. The key here is that you can strip out code that's no longer needed. Things like payment processing, analytics, and proprietary algorithms, all while keeping the core gameplay functionality intact. Make sure your game includes a direct IP connect option, as this would become crucial when centralized matchmaking is no longer available. All right, next up at option 2 would be to release the source code. This approach provides maximum flexibility for the community, but does require careful consideration of what you're releasing. You can release both game and server source code under a limited license where players can only use the code to keep the game functional and not for commercial use purposes. This allows the community to fix bugs and maintain missing features after end of life. However, other options are generally preferred because they keep the game functional without requiring additional work from players. And for option 3, you can release feature-complete games with save transfers. This approach works particularly well for games with significant online components that can be converted to offline experiences. For example, you release a standalone version that's free for owners of the original game, and importantly, you would allow save transfers from the online version to the standalone version. This would ensure that players don't lose their progress when the transition happens. All right, so let's take a look at a real-world example of how option 1 worked. A Spellbreak, developed by Proletariat, was a multiplayer battle royale game available on PC, PS4, Xbox One, and Nintendo Switch. When they ended support in January of 2023, they took the responsible approach of releasing a private server version for PC Windows users available for free. This is exactly what we mean by preserving the core gameplay experience. Even though the official servers went dark, players could continue to enjoy the game that they had purchased. The private server maintained the essential multiplayer functionality while removing the infrastructure burden from the developers. All right, so here's an example of option 2, Duelist, which was published by Warner Bros. Games and available on PC, iOS, and Android, which ended support on February 27th of 2020. The developers made the remarkable decision to release the source code to GitHub under a CC0 license, which is essentially public domain. This approach gave the community complete freedom to maintain, modify, and improve the game. While it requires more technical knowledge from the community, it does ensure the longest possible lifespan for the game, since dedicated fans can fix issues, add features, and port the game to new platforms as needed. And here's another strong example of open sourcing. It's called Caller's Bane, formerly known as Scrolls, developed by Mojang. Available on PC, macOS, and Android, it ended support on February 13th, 2018, but was officially resurrected as Caller's Bane and made open source. What makes this case particularly interesting is that they released both the game client and server files for download. The free client can join community servers and anybody can host a server. This creates a distributed ecosystem where the game's survival doesn't depend on any single entity. If one server goes down, for example, others can continue serving the community. Pretty cool, right? Nintendo's Animal Crossing Pocket Camp provides an excellent example of option 3. This mobile game ended support on November 28th, 2024, but Nintendo released Animal Crossing Pocket Camp Complete as a replacement. This is a masterclass in player-friendly transitions. They replaced the free-to-play, microtransaction-heavy online version with a paid offline version that removes microtransactions entirely. For a flat $20 purchase, players get access to all content that was previously behind the paywalls. Most importantly, they allowed users to transfer their save data, ensuring that years of progress weren't lost. This approach respects both players' time, investment, and their financial investment in the game. All right, now that we've seen some successful examples, let's step back and look at the broader context of what we're trying to achieve here. Game preservation isn't just about keeping old games running, it's about respecting the culture and artistic value of interactive entertainment, honoring players' investments of time and money, and ensuring that future generations can experience and learn from the games we create today. Creating an effective end-of-life plan requires thorough documentation and clear communication. Let me walk you through the essential components here. So first, communicate to players that the game has an end-of-life plan. This should be done early and often. Ideally, players should know from the time of purchase that you've thought about preservation. Contact players and let them know how long the end-of-life patch will be available for download. Give them a realistic timeline. For example, will it be available for 6 months, 2 years? Players need time to prepare. And then list out supported features that would continue working, such as single-player mode, direct connect options, and LAN play. Be very specific about what will still function. List out features that would be removed, such as matchmaking, leaderboards, or cloud services. Transparency here prevents player frustration. Include documentation on installing, running, or playing the game, especially if setup becomes more complex once official support ends. Consider that players may be setting this up years later on completely different hardware. Do your best to document any known bugs or workarounds that the community should be aware of. This saves everyone time and frustration. And if you own the IP, provide a clear written statement allowing for non-commercial use such as community servers or mods. This legal clarity is crucial for community preservation efforts. If a game can be modded, consider releasing tools or documentation for modders to extend its life. The modding community is often your best ally in long-term preservation. And finally, communicate what hardware or OS might be needed for the end-of-life version. If your server software runs on a different platform than the client, make this as clear as possible. All right, so what suggestions would we be able to give for existing games to move over to support their game at end of life? Well, for games that are already released but haven't planned for end of life, here are the most effective strategies. Release server software or tools that allow players to host their own servers. Again, this is the gold standard for game preservation. You can provide server binaries that allow dedicated community members to host their own servers, and this requires careful preparation to remove all the proprietary code and secrets while maintaining core functionality. Focus on creating packages that work out of the box with minimal technical knowledge required. Open source key components so the community can maintain the game independently, and consider open sourcing non-proprietary game logic, networking, code, and tools. This allows the community to maintain and improve the game independently. So start with less sensitive components like UI systems, utility libraries, or game balance configurations. Try to avoid releasing anything containing trade secrets, licensed third-party code, or proprietary algorithms. Do your best to provide documentation and assets to help fan projects continue the experience. You can also create comprehensive guides for server setup, configuration, and troubleshooting. Include game assets that players might need for custom content creation, textures, models, sound effects, and level editors. This documentation becomes invaluable when your official support ends and helps ensure knowledge transfer to community maintainers. Create official mod support or expansion tools before shutdown. Implement robust modding tools and APIs before shutdown announcement. This gives the community tools to extend the game's lifespan through custom content and modifications. Simple scripting APIs, level editors, and asset replacement tools can dramatically extend a game's community lifespan. Release a single-player or offline version that can preserve core gameplay. Create offline versions that preserve core gameplay mechanics without requiring server connectivity. You can strip out multiplayer dependencies and convert online features to local alternatives where possible. Note that this only really applies to games that were already single player to start with. If your game has multiplayer support, you should do your best to keep this functionality working at end of life. We're not asking to convert multiplayer into a single player experience. The key to successful game preservation is planning ahead. When you design preservation into your game from the beginning, rather than trying to retrofit it later, you save significant time, money, and technical complexity. So let's discuss how to build these systems from the ground up. Right, so how do developers reduce cost for an end-of-life plan? That's a great question. So cost reduction starts with smart decisions during development. Option 1 would be to avoid bad licensing agreements. Prefer agreements which don't have restrictions on giving binary versions of code out to players and don't have time limits. When you're negotiating middleware licenses, think about the end-of-life scenario. Some licenses explicitly prohibit redistribution or have clauses that make preservation expensive or impossible. Option 2 would be to use open standards and open source solutions that don't have these types of restrictions. Instead of using Amazon or a serverless database, you may prefer more open options like MySQL, or create a transition plan where MySQL can be used for community servers while Aurora is used at scale during active development. This gives you flexibility to scale during active development while ensuring community servers can run on accessible technology. Option 3 would be to code the game assuming services can fail or be removed. Make sure the game can handle service failures gracefully instead of crashing or showing cryptic error messages. This defensive programming approach not only helps with preservation, but also makes your game more robust during active development. All right, so what is the minimum viable build or setup that should be preserved? The minimum viable build is going to depend on your specific game, but there are some general principles to follow. All core features and functionality should still be present if these features were being used. This includes single player modes, multiplayer functionality, and local play or co-op features. The key word here is core. If a feature was central to the game experience, it needs to work in the preserved version. Some extra features and functionality can be removed depending on the game, particularly those not needed for that core gameplay. Examples include leaderboards, online ranking systems, and other microservices not needed for the core gameplay loop, like payments, account moderation, or anti-cheat systems. These are nice to have features that enhance the experience but aren't essential for the game to function. The goal is to preserve the essence of what made your game enjoyable while removing the infrastructure burden that makes long-term support unsustainable. All right, so what does it take to replicate your server environment locally for preservation? That's a great question. Replicating your server environment locally involves 3 main steps. Step 1 would be environment standardization. This includes containerization strategy, dependency documentation, configuration management, and resource requirements. You need to document exactly what your server needs to run, including operating system requirements, memory usage, CPU requirements, and any special dependencies. Step 2 is technical infrastructure replication. This covers database setup and migration, service coordination, network configuration, and monitoring and logging. The goal is to take your complex distributed production environment and create a simplified version that can run on community hardware. Step 3 would be community support tools. This includes automated setup scripts, development and testing tools, backup and recovery procedures, and performance optimization guidance. Now remember, community members may not have your level of technical expertise, so the easier you make this process, the more likely your game is to survive long term.